trigonometric functions, SOHCAHTOA. So for today's objectives, we're going to illustrate the three basic trigonometric functions, sine, cosine, and tangent. Recall that a right triangle is a kind of triangle that has one right angle and two acute angles. The hypotenuse is the opposite side of the right angle, which is the longest side of the triangle. The symbol angle, or this one, is used to indicate that a triangle is right triangle. So we can have here a square here. Opposite of this square is what we call the hypotenuse. So this will be your hypotenuse. And if you're going to have here an angle, or I'm going to represent the vertices as A, B, C. If I'm going to have here a reference angle, or that reference angle is theta. So if this theta that can be seen on angle B, so this angle B or theta, the adjacent side to theta is this one. This will be your adjacent side. And then opposite side of theta is this one. So this will be your opposite side. So for example, I want to move my theta at angle A. So allow me to change my theta. So adjacent side and opposite side also changes. So we're going to have here our theta at angle A. So meaning the adjacent side now changes here. You're going to have your adjacent side here. And then the opposite side will be here. Let's see the next slide. So parts of a right triangle. Again, we have here the hypotenuse. Hypotenuse is the longest side, and also it is located opposite the right angle. So here we have here the hypotenuse. We have here a reference angle. Since reference angle is at angle C, you can have your opposite side here. And if you want to look for the adjacent side, it will be here. This will be your adjacent side, the segment BC. So reading this one, triangle ABC is a right triangle with angle B as its right angle. Angle C is as its reference angle. The hypotenuse is segment AC. Segment AB is the opposite side, and segment BC is the adjacent side. So reference angle is the acute angle between the terminal side and the x-axis. It is always positive. It is indicated by the symbol theta. Angle C is a reference angle in triangle ABC. Opposite side is the side across the reference angle in a right triangle. Segment AB is the opposite side of angle C. Adjacent side. The side next to the reference angle is a right angle. Segment BC is the adjacent side of triangle ABC. Hypotenuse is the longest side of a triangle. It is always the opposite, the 90-degree angle in a right triangle. In triangle ABC, the hypotenuse is segment AC. So let's have here our formula for the three basic trigonometric functions. Sine of theta is equal to sine theta equals opposite over hypotenuse. Cosine of theta is equal to cosine theta equals adjacent side over hypotenuse. Tangent of theta equals tangent theta equals opposite over adjacent. So these are the three trigonometric functions that can be represented by the mnemonic SOHCAHTOA. So if you can remember this mnemonic, it will be easier for you to remember the equations or the formula for the three trigonometric functions, sine, cosine, and tangent. As you can see, for sine theta, the initial here for opposite is O. So if this is your sine, S represents sine, O represent the opposite side, and h for the hypotenuse. So sine of theta, if you want to remember, S stands for sine, so this read as sine is equal to O, opposite, and then the last letter will be the denominator, will represent your denominator, hypotenuse. Again, sine equals, or sine theta equals opposite over the hypotenuse. For the second formula, which is ka, if you have your ka, C represent cosine theta. So cosine theta for C, A stands for the adjacent side, so that will be your numerator. And then denominator will be the last letter, which is h, or hypotenuse. So cosine theta is equal to adjacent, A for the numerator, h for the denominator, which stands for the hypotenuse. Lastly is TOA. For TOA, we have your t. T stands for the last function, which is tangent of theta. Tangent theta equals O for opposite side all over A for the adjacent side. This will be your formula. So I hope you can easily remember the formula using the word or this mnemonic so, ka, toa. So these are the three basic trigonometric functions. So suppose we have here a reference angle at angle C. So if you want to look, for example, the sine theta is equal to, so allow me to represent the opposite side. If I have here A, so I'm going to represent the opposite side of angle A as small letter A. And then if I have your angle B, opposite of angle B, I'm going to have your small letter B. And for I have here a capital letter C, so opposite of that will be a small letter C. So if I want to look for sine theta, my formula will become, again, look for the formula. Sine, you can remember SOHCAHTOA. So O for opposite. So look for the opposite of our theta. Opposite of theta is C. So I can have here C as my numerator. For the denominator, again, so the last letter is H. That is the hypotenuse. So a hypotenuse here is small letter b, or side. So this is your sine theta equals C over B. And if you want to apply cosine theta, so we can have also cosine theta equals, again, using the mnemonic ka, cosine stands for adjacent over hypotenuse. So I need to look for the adjacent side first. The adjacent side of the theta here is A. That's the adjacent side. So that will be my numerator. Followed by, again, we have here the last letter H, which is the hypotenuse. And the hypotenuse never change on the illustration. So again, the hypotenuse here is B. So cosine theta is equal to A over B. For the last function, we have here the tangent of theta. So TOA, we're going to use TOA. The tangent theta is equal to, the formula is O for opposite side. So again, the opposite side of theta is this one, C. Over the TO, after O, we have here A, which is the adjacent side. So the adjacent side for angle theta is small letter A, or side A. Now we have now made our sine, cosine, tangent functions. Okay, let's have here our example. Refer to triangle ABC below. Find the trigonometric function values of angle A. In our illustration, we have here two sides, and the missing length of the hypotenuse is not given. So to look for the hypotenuse, you can use the Pythagorean theorem. So since opposite of angle C is the hypotenuse, I'm going to name this hypotenuse as small letter C. So to look for the C, you can have your formula for Pythagorean theorem, which is C squared equals a squared plus b squared. C stands for the hypotenuse, and A and B are the legs of the right triangle. So to solve for this one, first missing is the value of C. So we can have here C squared equals, and then A, we're going to use 5 for the value of A since opposite of angle A is the number 5. So I can have here 5 squared plus. Then B, opposite of angle B is 12. So I can have here 12 squared. Solving, C squared equals 5 squared, that is 25. Since 5 times 5, 25 plus 12 squared, that is 144. Next, adding the two numbers, that will give us C squared equals 169. Since we have here a squared, we're going to get the square root of the both sides of the equation. So C equals 13. Now, we can have two values for the value of C, positive and negative 13, but we're looking for the length of the side. So obviously, we can just consider the positive value, which is positive 13. So this will be your hypotenuse. So I can change the C to 13. Now we have now the values for the sides. We can now solve for the trigonometric functions values of angle A. Since we're looking for angle A, so we're going to have here sine A, cosine A, and tangent A. Since sine, cosine, and tangent are involved, remember the mnemonic for sine, that is so. For so, S stands for sine, O stands for the opposite side, H for the hypotenuse. So represent the hypotenuse, or for the opposite side, we can have here, since our reference angle is angle A, this is our angle A, the opposite side of angle A is 5. So write 5 over. The last letter is H, stands for the hypotenuse, and that is 13. So write 13 in the denominator. Next, cosine A. So the next is Ka. C stands for cosine, A for adjacent side, and H again for the hypotenuse. So again, we're using angle A. So this angle A, we need the adjacent side, which is A here. So adjacent of angle A, not 13, since 13 is the hypotenuse. So we're going to have here the adjacent side as 12. So 12 will be your numerator. And for your denominator, the last letter is H, stands for the hypotenuse. Hypotenuse is 13. Tangent A equals, so for tangent A, that will be TOA. Tangent A is equal to opposite over the adjacent side. So ang opposite side of our angle A, this angle A, opposite side is 5. And for the adjacent side of angle A, that is 12. There you go. You have now sine A equals 5 over 13, cosine A equals 12 over 13, and tangent A is equal to 5 over 12. Second example. Refer to triangle ABC below. Find the trigonometric function values of angle B. So this time, we're going to look for the trigonometric function values of angle B. Again, let's write sine B, cosine B, tangent B. Again, remember the mnemonics for sine, cosine, and tangent. So if you're going to start with sine, you can have here so. So for so, again, the formula is opposite of the reference angle over the hypotenuse. So our reference angle is B. So B is in here. So opposite side of angle B is 4. So 4 is your numerator. The denominator is, as you can see, the biggest number here is 5. So that will be your longest length. So that is your hypotenuse. Next, cosine B. So that will be Ka. For Ka, C for cosine, A for adjacent, and h for hypotenuse. So again, a reference angle is B. So the adjacent side of angle B is obviously not 5 because that is the hypotenuse. So the adjacent side is 3. 3 over the hypotenuse, which is 5. Tangent B. For the last trigonometric function, we have here TOA. Tangent equals opposite side over the adjacent side. So again, we're looking for the angle B, or that is our reference angle. Opposite of angle B is 4. Over, the last letter is A, which is the adjacent side. Adjacent side of angle B is 3. That's it. You have now trigonometric function values of angle B. Sine B equals 4 over 5, cosine B equals 3 over 5, and tangent B equals 4 over 3.